Okay, starting number 2. Brittany has a drawer full of unmatched socks. The drawer contains 30 blue, 30 green, and 30 yellow. She pulls 7 socks from the drawer and records the number of blue socks in that sample. So we're looking at how many blue out of the 7 she pulls. Is it reasonable to approximate the distribution with normal distribution? Okay, so reasonable. It's the word reasonable again. So we have to be looking at here, NP or NQ, or if we're looking if the sample size is less than a tenth. So if I'm pulling socks out and I'm not replacing them, so it's non-replacement, then this becomes a dependent trials because the probability changes every time you take out a sock. So we're going to use the reasonable, which is this. So if the sample size is less than a tenth of the population. Okay, so we're going to take the population and times it by 10% and see if our sample size is less than that. So we have 90 socks, which is the population, times it by 1/10 or 0.10. And that we get an answer of 9. Okay, so it's reasonable if our sample size is less than this number. So if our sample size less, in this case, we have 7 socks as our sample, and 7 is less than 9. So yes, it is. The sample size of 7 is less than 10% of the population. Which is 9. Okay, moving on to B. Determine the mean and standard deviation of the normal approximation. So we're hypergeometric, so we're using the average and standard deviation here. So U is N times P. Okay, so our N is our sample size, which is 7. Okay, and then what is the probability of success, which is P? P is the probability of success. So in this case, our success is pulling out a blue sock. So blue socks, we have 30 of them out of 90. So 30 out of 90. Okay, or 0.33. So if you multiply it, you get 2.33. So our average is 2.33. So if we were to pull out 7 socks on average, you get 2.33 blue socks. Now our standard deviation is the square root of NPQ times NP minus N over NP times minus 1. So we get the square root of N, which is 7. Probability of success is 30 over 90. Probability of not success would be 60 over 90. Times it by the population, which is 90 minus the sample, which is 7 over 90 minus 1. If you do all that calculation, you get an answer of 1.2. Okay, so average is 2.33 and a standard deviation of 1.2. Okay, now for the trickiest question. What is the probability that 3, 4, or 5 of the socks are blue? Okay, so now we're doing a range. So in the previous lessons, when we do a range, we're looking at 2 probabilities and then subtract them. So we were looking from 3 to 5 socks. So remember we did this before. When we have a range, we're going to take the z-scores of 2 and then subtract them. Probability of z-scores. So we're going to do the 3 and we're going to do the 5. Okay, so this is 3. If you think about it, it's 3 or higher and 5 or less. Okay, so 3 or higher. So it's 3 or more. So if you look here, 3 or more. So more and equal to would be subtract 0.5. So we're going to take 3 and we're going to subtract 0.5 and you get 2.5. So 2.5 minus our average, which is 2.33, divided by our standard deviation, which is 1.2. And you get an answer of 0.14 when you do the calculations. So this is 3 and more, and now it's 5 or less. So 5 or less, so equal to or less than. So fewer and equal to, we're going to add 0.5. So add 0.5 to 5, which is 5.5. Subtract the mean divided the standard deviation, and you get an answer of 2.64. Now we go to the table, and we get a probability. We get 0.5557 and 0.9959. Since we have the range, we now subtract them. Which gives us 0.4402 or 44%. So if you were to pull out 7 socks, 44% of the time, you'll have 3, 4, or 5 blue socks. Okay, I just want to confirm the homework. So I have 1 to 5. I'm going to take out a couple questions though. Where were they? There were some tricky ones in here, I remember. Let's see, I think they're okay. So 1 to 5. Just looking at the questions. Take out number 3 and 4. So take out 3 and 4. So 1, 2, and 5. Okay, 1, 2, 5, 7B, 8B, 10A, and 11. Just let me double check. 7B. Actually, take out 7B as well. So 1, 2, 5, 8B, then 10A, and number 11. Okay, and again, this was the last lesson, so I want to thank you guys for a wonderful semester. I hope everybody is home and staying safe. For any birthdays that I have missed over last month, which I believe it's a few of them, so happy belated. Let me just get those. So Kiara, Laria, Christina, and Aiden, happy belated for all 4 of you guys, and happy early birthdays for the rest who have I guess birthdays in the summer next month: Tasia, Isabel, and Harshal. And that is it, guys. If you have any questions, feel free to message me, and this will be the last lesson, so I won't be checking in much after this week. Hope you guys have a wonderful summer, and best of luck next year into all whatever you guys do, whether it's coming back, whether it's university or college or work. I hope you and wish you the best. Bye.